Hello and welcome to the Scratch Junior tutorial brought to you by the NASA IV&V ERC. Scratch Junior is a really cool program that's available on tablets, and I think it's a really great way to get our youngest kids interested in coding and able to do some really cool stuff. It's got a huge potential to tap into their creativity and storytelling, and it's a very simple interface that you'll be able to use by the end of this session today. Okay. If you want to follow along with this presentation, this link here, bit.ly/capital ERC, lowercase scr, capital J, lowercase r, takes you to the presentation that I'm showing now. That link is also in the comments underneath. So the first thing you need to do, if you haven't already, is download Scratch Junior to a tablet. That is definitely the option I suggest. iPads, Androids, either of those is fine. I believe you can also get an app on Chromebooks as well from the Android store. I do not recommend option 2, even though that's what I did, and that's downloading the Scratch port from GitHub. It has worked okay for me so far, but that is by no means an endorsement. It's not a super safe website to download programs from, so your computer's life is in your own hands if you opt to go that route. I picked it because it'll allow me to show you on my computer with my cursor where things are going to be. I definitely, if I were using this with students, would have them on tablets. Okay, so we're going to talk about Scratch Junior. We're going to make a program. I'm going to talk about some other features, what I would do if I was teaching this in a classroom, give you some links to online curricula in case you would like some more support, and then compare it to Scratch so you can see the differences and decide which is going to be best for your students. My goals for you by the end of this training session is that you'll make a program in Scratch Junior and decide how and if it fits in with your teaching. So this is the basic interface. Along one side, we've got the characters. In Scratch, they're called sprites. Scratch Junior just refers to them as characters. And then along the top, we have some other things. So let's switch over to Scratch Junior. Okay. One of the downsides of the desktop version is that it's not licensed to use the Scratch Cat, so your first program will have the Scratch Cat in it. By all means, use the Scratch Cat. I get Tick instead, and Tick's pretty great too, so it's not like I'm disappointed. If I want to add more characters, I would just click on this plus sign here. If I want Tick to have a background, so he's not just floating in white space, I'll go ahead and click on this up here. And Scratch has a wide variety of backgrounds to choose from, or I can choose to draw my own. The draw your own option is a pretty cool one. And one of the things you can do is also take a picture. This might not work extremely well to have a bunch of kids running around your classroom with iPads trying to capture background images. But if they drew something or painted something in art class and wanted to use that for their background, they could take a picture of their already existing artwork and have that be part of their background. Okay, I'm going to click OK, even though I don't really want that one, and then pick one for real. Let's put Tick on the beach today. Okay, so once you have your background in, you can always move this character around the screen wherever you want it to start out. And so I'll make sure he's on the beach and not in the water. I mean, I could if I wanted to, but I think I'll keep it a little bit realistic, at least to start with. So I've got a character, I've got a scene that character exists in, and so now the time is come to put some code in there. And before I decide on what code I'm going to use, I'm just going to quickly go through these 6 different palettes of code. Okay. This first one is called the triggering blocks, and you'll notice they all start with a curve, except for this one down here, which we'll talk about later. These blocks are the things that start the action, and all of Scratch Junior is designed to be pictorial and very intuitive. This one just means when you start the program, which is what happens when you click the green flag. This one is for when the user clicks on the sprite, and so on an iPad you would just touch it. And then this is for when 2 characters bump into each other. The messaging things we'll talk about later, but those 3 are the 3 triggering options that we can have that will then start our line of code running. The motion blocks are really straightforward. You can go in different directions. You can rotate counterclockwise and clockwise. You can go back to where you were at the beginning of the program, and then this one is a hop, so it'll come up and down. These looks blocks are, you can have the characters talk, so you could have Tick say something. These are getting bigger or smaller and returning to regular size, how they were when they started, being hidden and being shown. So if you ever want your character to look like they disappear, you would use this block and then they could come back by being shown. This is the sounds menu. It comes with pop already installed. And you can record your own sounds. That is something I want to caution you about. Sounds take up a decent amount of space. So if you have a classroom full of kids all running around with iPads recording long segments of noise, you're going to run out of space on those iPads. So from a management perspective, you should have a plan in place for how to deal with that. These are the control blocks. These are like the programming blocks that they have. This is a wait block, so it'll pause for a specific amount of time. This will stop something from happening. This allows you to control the speed and so make it faster or slower. And this is a loop. It will expand so that anything in there will be repeated however many times you tell it to. And then this last one are the end blocks. You can stop the program or tell it to go back to the beginning and repeat the whole thing again. So let's start by just having Tick walk around. And I want that to happen when I click on Tick. I just grab the block that I want and I drag it down here. This little watermark here, the little gray version of Tick, shows that this is the code that's with a Tick. If I have another character in here and I click to it, you won't be able to see Tick's code, you'd be able to see the other character's code. Okay, and then let's just have Tick walk. So now every time I click on Tick, Tick moves forward. If you haven't already, pause and take a moment to make whatever character you want and whatever scene you want move in your program, but Tick and I will just be hanging out on the beach while we're waiting for you. Okay, I click this to go back to where it started from. Now, what I want to do is to have Tick just go in a little circle and see how that looks. I'm going to do up. Okay. You'll notice that if you're familiar with regular Scratch, it does something for you that it doesn't do in regular Scratch, which is it switches so it looks like Tick is looking in the direction it's walking. This is a really nice feature for young kids because it's that kind of intuitive thing you would expect, and they've built it in so that's already pre-coded in there and you don't need to worry about it. Okay, so I've got Tick moving in a little square. But maybe I don't like how little of a square it is. Maybe I want him to go down farther along the beach before he comes back. So I can click on the number here and I could change it to 5 and then say I want him to go back in the same amount. And that's what this looks like. Okay, there's multiple ways to solve problems in coding. And so if you're experimenting or getting your students to experiment, some of them might move in 5 of these movement blocks to get the character to move forward. That's totally fine, and that is one way to solve that problem. It's easier and more efficient to do it this way, but there's lots of different ways to solve the same problem, and encouraging your kids to think of as many solutions as possible is a good way to get them sort of engaging in real kind of coding behavior. Okay, so we've got Tick moving around. Pretty fun. But I think we can do better, and we're going to do better by deciding to go to space instead. So I'm going to change my background to this lunar landscape down here. Okay, now Tick's on the moon, and Tick can do the same motion thing. You'll notice if Tick walks off one side of the screen, he'll appear on the other. That's kind of a nice thing to know about. So if I set this to I can't set it to 500. 99 is the most that I can set it to. It'll only take 2-digit numbers. And then click. Tick will just keep moving until Tick runs out of space to move, or until I stop it because I get bored because that's too long. Okay, so I want Tick to be able to get back to the moon, or sorry, back to Earth. But first, what I would like is for Tick to be able to breathe. And so I'm going to draw a little space helmet on Tick. So right here, this paintbrush is the symbol that allows you to get into the paint editor. I've got tick in here. I could change tick's color if I want. Maybe I want tick to be pink today. I can use the paint bucket, which is already selected, and then just click on part of tick to change tick's color. So now tick's pink. I can also draw, so I'm clicking over here. This tells me how thick my line is, and I'm just going to make a space helmet on tick. I'm not an excellent artist, but that's okay. I don't have to be to tell a story, right? And then just a big old space helmet on tick. Okay, make it a little more realistic. I'm going to give it like a little bit of shininess to it, like the light's reflecting off of it. And there we go. Now tick is safe on the moon, able to breathe. Okay. Next thing I want is to get a rocket. So I'm going to click on this plus icon here. These are ones that I've already drawn in my other programs. So it preferentially puts those ones that your user has created or edited on top. The next line is the kind of basic Scratch Junior sprites. Then you've got some animals. You've got some kids here and other people. You've got these people that have white faces that creeped me out at first, but we will come back to. They're not as creepy as they seem. You've got some kind of flora going on in the background. Some astronomical things. We're already on the moon, so we don't need one of those. Types of buildings, various objects, and then at the bottom we've got transportation. And one of the transportation options is the rocket. Okay, so I'm going to position this rocket over here. And I want there to be someone already as a passenger on the rocket, right? When we have people out on the lunar surface, when we would send astronauts out there, there would be someone waiting. So here we're in the editing panel. I can't actually show you the thing that I want to do. I can show you how to do it, but because I'm recording with my camera, I can't take a picture in Scratch Junior. If I click on any part of the rocket after I've selected this little camera icon, it will allow me to replace that section with a picture. So what I've done in the past is I've clicked on this little window after clicking the camera option and taken a picture that then will be in that window. So instead of doing that, I'm just going to reload in one of the rockets that already has a picture inside of it. But you can feel free to take a picture of whatever you want to put in there. So to do that, I'm going to get rid of the rocket. On your iPad, you would just press and hold on it, and then it starts wiggling and this red X shows up. On my version, I just hold down on it. And so I'm just going to grab one of my other rockets that I've edited that has a picture in it. And so there you can see the weird little face creature that I have to be in my rocket. Okay. The white face people then your students can replace with their own faces or faces of their classmates, of their families, and they can then they could also use that to put in pictures of artwork. If they're doing this at home, they could use stuffed animals or something like that and have different characters in the story, which I think it's a really cool imaginative option to include. Okay. So we've talked a little bit about sort of literacy and storytelling. One other feature is this ABC. If you click on that, it'll let you put a title on it. And you can make that font smaller or larger. You can change the color because there's no way I can see that on that background. And you can put in multiple lines of text. So you can give your Scratch program a title in that way. So those are some literacy things. Let's talk about math a little bit though. So this button right here will have a grid show up. Regular Scratch has a coordinate plane with the origin at the center. Scratch Junior has a grid with much bigger pixels on it, and it starts with the origin in the corner. So on this one, it goes from 0 to 20, or 1 to 20, I guess, on the x-axis, and 1 to 15 on the y-axis. You'll notice that when I click on the rocket and have it selected, it shows me which pixel it is in and highlights those numbers. And with tick, it does the same thing. So let's say I want tick to get to the rocket. I can do that in a variety of different ways. But if I was working with students and we were working on subtraction with numbers with 2 digits, I would probably ask them to turn the grid view on and do a math problem to figure out how far they have to make tick walk to get back to the rocket, right? So if tick's at 17, and we'll say the rocket's at like 4, okay? If we want tick to get to that point, I would do 17 minus 4 is 13, and then see if I could get this right on my first try. So now when I click on tick, tick should walk to the rocket. Okay, pretty good. So what I want to have happen next in my program doesn't really have anything to do with the grid, but I just wanted to make sure you knew it was there. But I want it to look like tick's going into the rocket. So after tick walks to the rocket, I want tick to disappear like he's gone inside. So I'm going to go to this looks palette and over here. Let's say I bring in the wrong thing. Let's say I bring in show. These buttons here are your undo and redo buttons, and you can click on them to undo things. So if I pulled in the wrong block of code, I can always simply drag it back up here and drop it and it will disappear, but I can undo here. If I go into the paint editor, you'll notice there's these buttons here too. If you have a student who's distraught because they had spent so much time making a drawing and then the drawing, they made a small mistake, they can undo their mistake. It remembers several steps back. So teaching your students how to use those undo redo buttons can be really helpful and manage some of the frustration. Coding is frustrating. It is not always going to do what you want it to do on the first try, and the worst part is it's doing exactly what you told it to do. You just told it wrong. You told it something that doesn't match with what your vision of what it should be is. So teaching students that it's okay to be frustrated with this and ways to manage that frustration can be a great soft skills instruction during the coding process, I think, anyway. Okay, so we're going to start our program over. So I want tick back where tick was to start with. Click on tick, goes to the rocket, disappears. Looks like he's boarded the rocket. Pretty good, right? Okay. The next thing I want to have happen is I want the rocket to take off and go to Earth. So I'm going to go over here. Again, I wanted to record a sound here, but I can't because it's using the microphone and I'm not fancy enough to make that happen. But I want it to make a sound like a blast off noise, like a countdown, 3, 2, 1, and then make the rocket engine go. And I also want it to start moving at the same time. There's a couple ways to solve that problem, just because there's a couple ways to solve every problem. But what I'm going to show you is the way that involves sending messages. So when tick bumps into the rocket, when tick first gets there, I'm going to have it send a message. And there are 6 different colors that of message that you can send. I'm going to go ahead and have it set to yellow. And then I can have 2 different things happen at the same time. Okay, so if it receives the yellow message when they run into each other, it's going to play the popping noise. Again, I want to record something better, but this is what we got for now. And then let's have the rocket wait a second, like, because I would have had a countdown. Let's have it wait a little bit. Let's say 5. And then start moving up. So let's go to the motion and we'll go up. How far up? Let's try 4, see what that looks like. Okay, so we're going to start our program over. Click on tick. You heard the popping noise, hopefully, and then the rocket rose up into the air, okay? After it rises into the air, I want it to turn towards Earth. So let's see, is that going to be enough of a turn towards Earth? Oh, not even the right direction. I don't know what I was doing. So let's try 3. Okay, perfect. Now what I want to have happen is I want the rocket to go towards Earth and also get smaller at the same time. So it looks like it's traveling in at least 2 dimensions, right? So it's getting farther away from us and closer to Earth. So to do that, I'm going to use a loop. Okay, and inside that loop, I'm going to say shrink and then move. So I'm going to pick this one where it's getting smaller. And it looks like it's full right now, but I promise it will expand to fit as many things as I want to put in there. And then I want it to go towards the Earth, let's say 3, and see what happens. Pretty good, right? It got there. Okay, so this is a neat way to use a loop because I'm doing the same thing again and again. I brought in 3 blocks to do this. 4 times 2 is 8, so it would have been 8 blocks to do it if I just repeated one thing after another. But it's definitely more efficient and it's easier to keep track of. You're going to make fewer mistakes if you're using loops, so there's a lot of good reasons to. And so that's one way that you can use a loop. So the next cool thing that I want to show you about using Scratch Junior is over here, and they're called pages. So this is our first page, and you can see the one up here. Let's make another page for when Tick gets back to Earth. So, oh, no, not what I wanted to do. Good job. It brought in regular Tick. I want space Tick. So I'm going to get rid of regular Tick by pressing and holding and deleting. And we're going to have like a ticker tape parade for Tick. Ticker tape, pretty good, right? Okay, so I'm going to go in here and see if I can get a car. It's not a convertible, but you know what? We'll make do. We'll have Tick on top of the car. In Scratch Junior, whatever is in front is the thing that you manipulated last. So if I wanted Tick to be in front, I would drag Tick around. If I want the car to be in front, I'll drag the car around. Okay, it just looks like the Tick is being really unsafe, I'm realizing now. So we wouldn't do this with students, right? Okay, and then I'm going to manipulate this so it looks like moving through on the road. I'm being way too picky about how this looks. This is not the big deal. Okay, and then I'm going to put up here, welcome home Tick. Well, that's terrible. I can't read that at all. Still bad. I don't think I'm going to get a good read on it. This is hard to watch, I know. Okay, good enough. We'll do black text. Okay, the point of all of this is now I have a second page in my story. When I go over here to my various ending things, I can go to the next page in my story. Oh yeah, look at that. I can keep scrolling to go over there. Okay, so now here's the whole program. Tick goes to the rocket, disappears. I don't have it wait long enough, so it looks like Tick is like ethereal and disappearing. So I'm going to fix that. And then it goes to this welcome home Tick page. Pages are really cool because it's like a story. You can go from one scene to the next. But you can also do some really cool coding things with it as well. One of the problems I had with Scratch Junior when I first started using it is like they don't have any conditional statements. They don't have any variables. How is this at all like real coding? You can get around it by using those pages. Those pages are like your conditional statements. So let's say you present your user with a choice on page 1. They can click on an apple or click on an orange. Each of those things can then send out a different message. If you click the orange, it could send a red message. If you click the apple, it could send a green message. And those could take you to different pages. They could also make a complete copy of one page and just have the code be different. So there's different behavior, but it looks the same. So there's some cool things you can do in there, getting probably more advanced than you want to be with your students. But that's definitely an option. When you click on this yellow tab up here, you can name your project. And on your version, if you're on an iPad or a tablet of some kind, there should be a button that allows you to share. The sharing is protected with a simple math problem that I think is pretty easy for a lot of students to be able to get through. And then you're able to send in an email address that you would send it to. So this is a way that you can have students send their programs to you so you can look at them. It's a way to send it to families in case you want to share what your students are doing. And so the sharing button on here is definitely something that you want to be aware of, even though it's you have to trust me that it's there. So just to give you a different idea of a simple game, I'm going to go back to my home screen. And this is one of the first projects I did. When you click on Tick, Tick jumps. and you're trying to avoid getting hit by talk. So if I start the program, tick jumps in the air and avoids talk, but if it hits talk, it says womp womp and spins in a circle. You can still make tick jump in a circle, but it doesn't work very well. Okay, so that's a really simple game to do. Talk has just this code of go fast to go forward again and again. I'm going to stop it so that noise isn't happening. So all talk is ever going to do is just scroll quickly across the bottom of the screen. To make this easier, you could slow talk down. And then tick's code just says, when clicked, jump. And then forever, if you're touching a sprite, make the womp womp noise and spin around in a circle, which is a loop, so it'll get back to the beginning. Okay, so that's a really simple other program. Let's go back to our presentation here. And again, the link is below if you want to get to this. It has a really short overview of what the different palettes are, and just for your reference so you can look at them. That's the Scratchcat if you haven't seen it. And then here are the features that I really like. Pages we talked about. The undo and redo buttons are so important. And then the grid view is another thing that's pretty cool, where you can build some math practice in a really authentic way to get kids to solve problems that they want to solve for their program. Okay, this is a short tutorial of how to use the blank face sprites. And so I picked out the pilot, and I put a picture of my cat's face into the pilot there. So it's like some cats flying cats around. And it does not just have to be faces. It could have been the whole plane. It is up to you. This is a version of the program that I just made. And so you have that for your reference as well. Sometimes that's nice to have. If I were teaching this to a class, I would either start or end with WeDo or Coding Express. The WeDo platform in particular is going to be such a good match for Scratch Junior. You can see from the interface down here, the blocks are extremely similar and how you code is very similar. It has an iPad or Android app on it, and it will guide you through how to build the various robots that you're going to be making with the WeDo kit, and how to build the program for it as well. It's a little bit more complicated than Scratch Junior, so I might start with Scratch Junior and then go into WeDos, but I could also see a good argument being made for using WeDos first because they're tactile and hands-on and giving kids some meaningful experience with coding in the real world, and then transferring that to the more cerebral Scratch Junior where they're just seeing things move around on a screen. Another thing I might do is modify NASA's Flyby Math curriculum. It's designed for grades 5 through 9 to work on algebra, but the premise is really simple and definitely can be used to teach coding concepts to younger students. So what you do for Flyby Math is you tape out various tracks with tape. They usually have a kind of Y shape, and then you've got 2 students who are pilots and a student who's an air traffic controller. The air traffic controller's job is just to say step every second or so, right? So they're just regularly saying step, step, step. And then the pilot, depending on what speed they are flying at, will take a step every 3 times the controller says step, every 2 times. And so the algebra is trying to solve these problems to see if the planes are going to run into each other in these various situations. You could definitely adapt this idea to just involve, okay, you are going to pretend to be your robot following your code. This is what you are told to do, and so this is how you're going to follow through. And it's a way to make it more concrete and being able to act it out in a sort of no-tech situation. There are some really good online curricula for Scratch Junior, and I'm going to flip over to this and look through some of them. The animated genres one is a little bit more advanced, so if you've got older students, that might be what you would want to start with. And by older students, I mean like 1st or 2nd grade instead of kindergarten. It's either way, it steps you through lesson by lesson, going from some really simple things to more advanced, and ending up with the students making a game that is going to be really fun and satisfying for them. If you need something that's a little more simple, this reinforcing literacy and math curriculum is great. you're going to include some identifying upper and lowercase letters. And then counting and cardinality is another lesson there, where you can have just copies of different sprites in there and being able to do some math work with them, which is pretty fun. PBS has a pretty good set of curriculum. Their lesson plans are pretty in-depth, and we'll kind of walk you through the whole thing from anticipatory set onwards, and they have some good ones. I like the Scratch Junior Boot Up curriculum. There are so many lessons on here. This is designed to be done from kindergarten through second grade. So don't feel overwhelmed, and you can definitely pick and choose from here. But I love that they sort of design them in sequence. So the ones at the beginning are designed for students where it's their first year using Scratch, the first quarter of the year. So very, very much a beginner. And then all the way through towards the end, these are ones that are designed for their second year using Scratch and later in the year. One of the great things about this is that Boot Up also has a Scratch curriculum that's set up very similarly and sort of picks up right where this leaves off. So if you're wanting to transition your students from Scratch Junior to Scratch, or you think, wow, I really would rather be doing Scratch coding, but I want my students to get some experience with Scratch Junior first because it's so much simpler, I would definitely lean on the Boot Up curriculum there. One other thing I would point out is that, and there's a link to this in the presentation. Let's see, it's this one here from the Scratch Junior website. This is absolutely something I would have printed out and laminated and put magnets on in my classroom. They're just paper-sized motion blocks and all of the different blocks in Scratch Junior. So if you're wanting your students, especially at the beginning, to do exactly the same program as you can take these and put them up on your board and say, okay, make these steps in this order. So it's a way for you to be able to demonstrate what your program should look like, or one way to solve the problem. And it also is something that you could get your students involved with, where they are showing their peers how to copy the programs that they've made. Okay, so I've talked a lot about Scratch Junior. I want to talk a bit about regular Scratch. And so I'm just going to show you one of the programs. We have a tutorial for this on our channel, the Math Maze. And so I do like caveat every time I go in and look at the code in a Scratch program, I'm immediately overwhelmed. It's always more than I'm expecting it to be. So I'm going to break it down for you what these different parts do. In this one, the start blocks have way more options than just when a sprite is bumped, when a sprite is clicked, and when the program starts. You can actually use the keyboard keys to control elements in the program. So I have this little yellow ball, which is the sprite that I'm on right now, set up so that when you press the arrow keys, it moves around the maze. Okay, so that's how you control the ball to get it through the maze. This code down here, oh, I'm not actually running my program. I should probably start it. This code down here says that if the ball is touching the color black, which is the color of the maze, it's going to ask a math problem of the user. Okay, and so it's using variables, which I created. It's picking random numbers from ranges that I've set in there. It's doing some subtraction to figure out what the correct answer is once it picks those random numbers. It's asking the user a question and then checking to see if they get the right answer. So if I put in 10, it just tells me good job and then puts me in the opposite direction of where I was before. But if I answer incorrectly, it'll send me back to the beginning of the maze. Okay. There's a dinosaur in here, but all the dinosaur does is if the ball touches the dinosaur, it does like a little dance by switching through its costumes. So Scratch has a lot of conditional statements that you can use that'll say if this happens, then do this, otherwise do this. They have a lot of math in these operator fields, so you can have it do math problems. You can have it compare numbers. It's even got the modulo function down here. It's got variables that you can set and manipulate throughout your user's actions. So it has a lot more robustness to it. It's designed so that you can sort of ignore as many of those features as you want and use it with kids, probably third grade and up. But I definitely used it in the middle school classroom, and you can make it more age appropriate for older students by using actual images. The NASA and Scratch tutorial that we do uses real images from the surface of Mars and the Mars rover to create problems that students need to accomplish. So there's a lot of good reasons to use Scratch, and I think Scratch Junior is just a phenomenal way to get started with these things. So I've got my little comparison there. There's a couple more things. If Scratch is something you're interested in, like I said, Boot Up is a good one. CS First is another great resource, and I've got a whole video on that on our YouTube channel. It is designed for teachers who want to teach coding but have no computer science experience and do not feel comfortable leading their students on this experience. So it has a lot of video support for the students where people who code talk them through what they need to do in their program. So it's a guided experience, but they also have add-ons that students can select in each of the modules to make their program a little bit more personal and give them the experience that they need. These last links on here are for our Scratch resources that we've developed. And if you missed the link before, it's just bit.ly/blah, blah, 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 blah. That one down there. Okay. I hope that this was helpful and that you have had some fun and made a Scratch program Scratch Junior program along with me today. I certainly have enjoyed playing around with it just immensely, and I just think it's a lot of fun. It's something I wish that I had been able to do when I was a little kid, and it just thrills me that we're able to provide our students with this experience from kindergarten and up.